Hello everyone, in this video I'd like to introduce an old school Go Weiqi Baduk playing program that I've developed in Python. So I had several attempts so far, and the very latest attempt to create the Monte Carlo research based Go playing program didn't end up with a success, I would say. So there was a series on this, but I've abandoned the series because, lots of things uh, has been preventing me from doing that. But essentially, what I've realized is that trying to follow modern trends, like what should have been done, like the way it should be done, is first of all, it's opposite to being minimalist. And for me, being minimalist is like very important thing to consider. And also, it's not very didactic as well. So in today's world where neural network based coupling programs are dominating the market, let's say, it's very hard to find somewhat an old school program. So one of the uh, dinosaurs, let's say, of old school Go is GnuGo. Current version is 3.8, if I'm not mistaken, at the moment of recording this video. So that program, GnuGo, relies on handcrafted heuristics, and it doesn't have multicolored research. It has some experimental for 9x9 board, but for 19x19 it doesn't have any. So interestingly, that all handcrafted heuristics-based Go-plane programs before introducing multicolored research um, take take its origin from a program called Wally by Johnson K. Millen, which has developed this for the unexpanded K1 with only 1K RAM. And the heuristics that Wally did use was simple patterns for attack, defense, and pattern matching as well. So this was the inspiration for the GnuGo. There also was an implementation by Bill Newman, who has ported this to C. There was no any source code, only the article in the Byte magazine and just the bare explanations of how things should be working. So people tried to implement that their very own ways, and some enhancements has been introduced. So my project is another attempt to implement ideas from Wally in Python in my case. And I had another series where I was like I was trying to implement exactly Wally and exactly in Python as well. But that was very miserable in terms of both in plain strength and even the rule of code wasn't properly implemented there. So this time I have like normal implementation of rules. The rule of code is implemented, and also the way how the handcrafted heuristics is working is quite interesting. So my program can be GnuGo version 1.2, which is the first publicly available release of GnuGo, and it's about even in strength with Wally Plus, which is the C++ enhancement of the Wally.c by Bill Newman, which has created his program based on the article of Jonathan Kim by Jonathan Kim Millen. And Wally Plus already have the influence estimator, very simple but still. So my program is about the same in strength as Wally Plus, but it uses less patterns than Wally Plus has, like plenty of patterns. My program only uses is only using 12 patterns. I want to very quickly walk through the source code, and then we'll see how the program is playing against GnuGo. First, we'll probably see how it plays against itself, then against GnuGo, and finally, maybe I will play a few moves against it because, well, playing with a human player doesn't make much sense because it's very easy to win. But anyway, so here is the source code. So not many variables to keep track of, essentially. So we have the board size, width, the board is two-dimensional array, side to move, cool, and groups. So one of the enhancements that I've added compared to any previous Go playing program I've been developing is that now all the groups are being tracked and incrementally updated during the game. So we know we have a list of groups and we know which stones are which stones does the group contain and how many liberties. So all the information regarding groups is being stored along the game, which helps to decide which group to attack or which group to defend based on the amount of stones and number of liberties. So let's say the group that has the biggest amount of stones and the least amount of liberties is something that we want to attack. On the other hand, same group, but our group, so biggest group with the least number of liberties, that's the one that we want to defend. So these are the 12 patterns that would be applied. It's one of the core parts of the entire heuristics. So init board, bring groups, nothing special so far. So count routine helps to essentially find, it returns the array, which is like a board array, which contains the group with stones and liberties being marked. Then addStones takes this marks as an argument and it extracts stones and liberties coordinates and stores them as a group. The make group makes a group. Update groups looks for all the board and finds all the groups available and essentially creates the database of all the groups that are available on board now. Is clover or is diamond. So it looks for the diamond shape, and if it finds one, it returns the color of it. It's used to prevent playing into the own eye, and also it is used to implement the rule of co. Is suicide tracks whether you're trying to extend the group so that a self-capture queue. So to avoid that, is suicide is used. Is Atari checks whether the stone where you're about to play finds itself in Atari after being played or not. Get influence is the idea that I've taken from Wally Plus, and essentially it's used to find biggest places on board. Yeah. So whatever the biggest uncrowded place on board we find, we want to put a move there in the early stage of the game. Play is the routine to set the stone on board, handle captures, and update the code. So big moves is the function that makes use of the influence function to essentially find biggest moves on board. And also, apart from that, it also has the urgency value, which is based on the influence function. Okay. Rotate pattern is used to make sure that all these patterns that we have can be rotated 4 times, 90 degrees each time. And swap colors is used to change the colors. So here we use like black, but it also may be for white. Here it might be not white, black, but black, white, etc. So hopefully that makes sense. Swap colors, make patterns. It creates the pattern database with all the rotated and all the color swapping patterns. So essentially like 12 multiplied by 4 and multiplied by 2. So that's the eventual number of patterns. Board to 3x3 patterns is done to create a board, return as a list of the 3x3 patterns, just easier to match with our 3x3 patterns. And match pattern essentially finds the pattern that we have in a database if it's available on board. Ladder function, something that Wally does not have. I think neither GnuGo 1.2 has this kind of thing. So I've implemented this ladder on my own. This was quite a fun experience. So if it can capture a stone into a ladder, it does. If it cannot, it does not. So if ladder breaker is there, it's not going to chase the ladder. So this is the recursive function, and if it returns the move, chasing move to try to capture the stone in case if ladder is working, and it returns 1 if you can escape the ladder, and it returns 0 if you cannot do neither. If you can do neither. Check ladder is just a wrapper for the isLadder function. We just work on a board copy. I mean, we do this on board, but we just preserve the copy of board. Okay. Attack and defense are functions intended to like considering fighting moves. So we can either have our capture, and we every type of move we do, we calculate urgency. We'll come to that later. So this might be either capture, or it might be a ladder attack. It might be a more general surrounding group kind of scenario. So we want to attack the weakest group by limiting its liberties, by putting stones where the liberties are. So looking for the biggest group with the least amount of liberties. And exactly the same for defense. So try to save the group. If ladder works, then we don't save. If ladder does not work, then we do save. Same for extending the group. Okay, we rarely hit this. Surround is hit sometimes. By the way, surround is good for killing stones. It often destroys the eye shape. Although this program knows nothing about 2 eyes, but it tries to eventually create groups that are alive. So yeah, and extending the group most likely doesn't work. So the way how surrounding and extending works, the closer to the center the move, the closer move to the center, the greater urgency it has. So generally helps to like building walls and closing territories naturally. Calculate urgency is the heart of the evaluation because when I try to implement Wally, like just by reading the article and even try to make a YouTube series on this, the problem was the move priority. So different implementations use different ways how to handle this, but essentially, eventually, what I came up with is having the urgency value. So each move is associated with the urgency value, and depending on what kind of move is that, we have a different urgency. Also relative to the board size, so that in theory should be playing similarly on any board size. So we might have a big move, and the size of the group. I mean, it's not the size of the group. I mean, this group is used differently. In case of, it's not really group always. So sometimes the group, in case of attacking and defensive moves, it's real group. But in case of in case of big moves, say, the group is essentially just the urgency value derived from the influence function. So it's a little bit unclear maybe, but anyway. Python allows us to have the different data structures being passed here, so it's okay. Also, we give the urgency to the pattern, so trying to consider those patterns closer to center. I don't know if this is good or not, but this is how it's done. Also, we are considering the weight, and again, group in case of pattern is how many stones involved within the group. The more stones involved, like the stones are encoded as integers, the bigger value we have by adding all those integers, the more valuable this pattern move is considered. So the values within the patterns themselves are used somehow to prioritize one pattern over another. Okay, and finally, for the fighting moves, the distance to center to effectively surround, efficiently surround, and urgency is calculated by we divide the number of stones within the group by the amount of liberties within this exactly the same group, and that's how we calculate for captures, for surround moves, for ladder moves. So ladder has bigger priority for like save moves and for extend moves. And finally, we come to the generate move function. So essentially, these are the four heuristics that are used within the program. So taking big points if possible, matching patterns, attacking opponent's weakest group, and defending own weakest group. So we just generate big moves, and once we generated those moves, they are already available with urgency values. Then we generate pattern moves, all the pattern matches available also with urgency values. Same for attacking moves, for defensive moves. So there will be only one attacking move, there will be only one defensive move, there will be only one surround move if that's attack or extend. So either capture or extend or surround, just one move for attack, one move for defense. And finally, we just sort this moves in descending order. And the move that has the biggest urgency within this entire list, there might be plenty of moves, like really lots of moves, especially in the early stages of the game, like maybe like 50 something. So the move with the highest urgency is considered to be the best move and is returned by the gen move. So move to string just to help a function to create the board column and row to algebraic notation. GTP handles the GTP communication between the engine and the GUI. Finally, we just run initializing the board and run the GTP function. So let's have a look how this works. It's much easier, much more interesting to have a look how this works. So at the moment, I make my engine playing against itself. So 5. Yeah, now it's playing against itself. So what it starts with, it just tries to take big points, corners, sides, but also it would be trying to grab some territories in the center. Sometimes, so this is the pattern matching. See, this is also the pattern matching. So now it's more likely to be doing pattern matching moves. Like watching engine playing against itself is probably the most satisfying thing to do because it clearly shows all the heuristics in action, how it works. I personally really like it. Yeah. Sometimes shape sucks, but we only have 12 patterns for that. So yep. So like it tries to split, it tries to cut. Essentially, it will probably kill this. Maybe not. Um, yeah, connect his groups here. So now these stones are about to be dead. In the meantime, yeah, probably black is going to win this. And also, it has some randomization, so it would not be playing exactly the same game every single time. We'll be playing different games all the time. So, yeah, really lots of games. Yeah, I need to say that black is doing fantastically well, although this black group is most likely going to die. It depends who wins the capturing race, whether black would capture this or white would capture this. I think that probably white will capture this and save this group. It's more likely to happen. You see, sometimes it makes moves that help to improve the eye shape, which is great. Okay. Yeah. So yeah, this group looks to be dead at the moment, although yeah, maybe after this move, yeah, maybe it's no longer dead. Okay. Great. Now this black group might become dead suddenly. And oh my goodness, this group also might become dead. Yeah, so black was much better, essentially winning the game, but now I'm not really sure if if black is still going to win or not, because white is taken over really nicely. Yeah, the most satisfying thing about this project is when you watch the logic that you've implemented on your very own, how it works, and yeah, um, I'm quite satisfied because all things I told it to do essentially does all that. Okay, look at this beauty. See, like it just connected his groups. Now he's alive downside. White is alive in the center. Still not sure. So is this... Now this group is a big question. So he needs to play one move here to have a living group. Black needs to play here. Okay. Oh, that was unfortunate. Yeah, seems like white is really taking over. So this Yosa move, it has the least priorities because Yosa is to be played in the... Oh, okay, he decides to... He makes two eyes here. What a fantastic save. Yeah. But no, this group is dead, you see? So this is Ko, so this group is going to die. Yeah, interesting. What about this group? It's alive? Yeah, it looks quite even. Yeah, and it kills this corner. Whoa. Well, maybe not yet, but in order to kill the corner, black needs to play Hana here. Okay, he takes this one. Great. So the reason behind this move is it just tries to destroy the eye shape. So programs that do not know how to... programs that know nothing about eye shape, yeah, and kills this one. Cool. They just tend to destroy the eye shape if it's possible. So essentially, these are the surround moves. It's the way how they work. Okay, and yeah, we are done. So let's have a look. Score: black plus 6.5, which is essentially a round even game. So yeah, it's quite even game. Great. So now my program would be playing only white, set as white, and GnuGo1.2 is going to be playing black. Set as black. Unfortunately, GnuGo1.2 has many bugs, so I need to be very careful, and if it plays an illegal move, often it may play overwriting my stone. Yeah, so I need to pause and try to generate another move. I need to be very careful. Anyway, let's have a look. So GnuGo1.2 is playing black, and my program is playing white. It seems like GnuGo1.2 also has sort of a influence function of some sort. But already you see like white takes two corners and dominating, while black feels like over concentrated. Okay, how do you like this? Yeah, it's cool, isn't it? Yeah. Yeah, white just takes territory, which is amazing. See, like it's about to capture this one. So black is very limited here. Okay, black is very limited. GnuGo does this weird pattern matching, building this diamond shapes all over the time. I also had this in my engine, but I got rid of that, and generally it makes my program playing much faster, not wasting time for this moves. Because just trying to make a shape this way is like too slow, doesn't quite make sense. So yeah, it's 100% alive, but it's not particularly going anywhere really. So I think that the advantage of my program is clearly seen here. Okay. Yeah. Probably GnuGo is going to live in this corner, but not obviously. Sometimes it plays like weird moves. So this still can be killed, believe it or not. GnuGo can give this away. Okay. Yeah, you might say that both programs playing quite weird moves, but they are about the same class. Yeah, this corner is now alive. Okay. So we are about to end up quite soon. I'm wondering what's going to be the score. Okay. What is going to be the score? All right. Yeah, the fact it plays the game to the very end is very satisfying on its own, really. Okay. Still, it's quite random, so it really depends on the random behavior of the influence function in the opening. It's probably the most, something that decides the game the most. Okay, GnuGo stocks, that's because it's about to pass, but the GTP placeholder that I've added to this just makes it hanging. So essentially, this means that GnuGo is no longer going to play. So let's score the game. So white plus 3.5. So white won. Sometimes it's not such a crushing win, but it's still a win, and also it's white stones. Sometimes it's much more crushing than this. Anyway, let's try now to make my program playing black stones and GnuGo playing with white stones. And create a new game. And here we go. So my program is now playing black. And GnuGo is playing white. Usually bugs are happening when GnuGo is playing white. For some unknown reason, I don't know why. Okay. This is a very, very naive go, for sure. Yeah, but how do you like this cut? Okay, you see this? Yeah, that's the bug in, hold on a sec. This is the bug within the GnuGo. So just overwritten my stone. So this cannot be done this way. So I want to generate another move. Okay, now it generates another move. Okay. So nicely taken the corner. Empty triangle is not good, but it's not about empty triangle. I was just trying to pip this 2 stones. So yeah. Yeah. This is the most commonly used pattern. 2 stones, playing 1 stone in between, then protect. The best preferred pattern for some unknown reason. See, like it's happening all the time. If it's not defended, then it goes further. Okay. If it's not defended further on, it would just try to squeeze it. It's not the best priority at the moment, so yeah, things happen. It's going to be later. Yes, it's still cut. So try to split, tries to cut. Okay, this group can die. Not good. But if it manages to kill this, then it would be just amazing, really. And if it manages to connect with this one, this would be even better. Yeah, and it connects. Whoa. Yeah, I really enjoy this. See like how nicely connected. Okay. Yeah. Nice cut here. Also needs to play this one to completely cut this stone. This may or may not happen. It's a bit hard to say at the moment. Plenty of things to be done, so playing here and here is also quite important as well. In that case, all this is going to die. Yeah. If not, well. Yeah, sometimes it plays this move towards own stones, which doesn't quite make sense, yeah. But anyway. Yeah, black is clearly dominating, so black is about to grab all this. White only has this small chunk here. Okay, hold on a sec. Something has gone wrong. Did I? Okay, just click somewhere. Okay. Just click somewhere so that it just stops following the last move being played. Yeah, all these stones are dead. Okay. And these attempts are not going to work. And calmly defend here. Okay, Atari. Okay. Yeah, so despite the fact GnuGo is trying to invade, it's not possible, there's not enough space to make a living group. So it's all going to die. I have a little concern that this may connect, but hopefully not. Hopefully not. Okay. Okay, nice. Now this is really nice, you see. Yeah. Yeah, white is doomed here. So I'm really waiting for these moves to be played by either side. Yeah, this is that. This is not going anywhere. Okay. Yeah, and yeah, my program cuts GnuGo stones here, which is so amazing, yeah. And I would just kill all these DAG groups. Yeah, what a beauty. So cool. Yeah, and it kills. And it kills. So one Yosa move here, you might ignore. Yeah, I would be trying to kill dead stones. Would be trying to kill these dead stones here. So yeah, it turns out to be a bit smarter than GnuGo, although the amount of knowledge apart from ladders, I guess, is the only difference where my program has more knowledge. But the game is won not because of ladders, essentially, but although it's quite interesting usually to see how GnuGo is trying to chase my group with a ladder, not knowing that is going to be saved, but my program knows exactly that the ladder is going to be saved, or if it chases the ladder, it knows exactly that it will eventually capture. So this is quite cool. Okay, so all these groups are dead. GnuGo no longer plays, which means it's a pass move. So let's have the final score of the game. This is also dead because only one eye here. It's literally impossible to build another eye head. It can only be a coast, so this would be killed eventually. Black is black plus 114.5, so the crushing win here. Yeah, usually plays around like this with white stones as well. The previous game wasn't that fortunate because of poor random considerations of big moves in the opening. It just happened that wasn't really that great. But generally, it wins games against GnuGo. I also try playing versus the Wally Plus, which also beats the GnuGo, which was sort of an inspiration for this program. And most of the time, Wally Plus wins because it just has more patterns, but sometimes my program also can beat that one as well. Well, okay, so now I want to demonstrate how I play. This is my program. So let it be black. Yes, new game, don't save. I want to play starting with 9x9 boards, and I give my program 4 stones handicap. Okay, and I kickstart with white stones. So I need to be careful. Okay, let's take the corner. Just taking the corner. And yeah, probably need to try to split. Go in here. This is not going anywhere, so it's okay. Now I need to block. Okay. Yeah, I think I won the game. I could show some mercy to like give an idea regarding the strong parts of the program, but yeah. Ladders are interesting, how they work. But satisfying thing here is it essentially it can complete the game of Go, which is great. So yeah, this was an eye shape. It would have been destroyed, but yeah, doesn't matter really in this case. So takes, okay, takes. And it passes, and I pass. Yeah, I won by almost 30 points, but yeah. It's not really interesting for a human player to play this way, but yeah. Okay, let's try now 13x13. So don't save. Let's make it 13x13, and let's give it 9 stones handicap. The biggest possible handicap in this program. And well, I start with taking the corner. Okay. So just want to show you. So I will try to invade the corner. Yeah, it would now be considering big moves, so I guess it's not a problem to take the corner here. Yep. Although I need to be very careful. Yeah, because yeah. So this is that, but he's also threatening me to. Okay, you see, like it's not defending the ladder. Although yeah. Why didn't defend the ladder? I'm wondering. Yeah, not the best ever example, I guess. So not the best ever example. Yeah, if it happens that ladder code would fire, I'll demonstrate that. Okay. He can even make a living group here. So for now, I would not kill this. Maybe he would save the group one day. Well, essentially, I need to play 2 moves. So if I play here, then I will kill the group. But I'm not going to be doing this, at least for now. So yeah. Okay. Would it be better to cut this one? You didn't do this. Okay. Yeah, territory-wise, he's doing not that bad at all, you know. He's doing not that bad at all, territory-wise. Is he going to cut? Nope. He gives me a chance, yeah. He gives me a chance. It gives me all the chances in the world. Yeah. I'll probably kill this. Can't you see this? Yeah, he cannot see this. Okay. Yeah. Well, it doesn't have any look ahead. It knows nothing about living or dead groups, so it's not a big deal. No, not a big surprise. Plays this way. Well, essentially, if I wanted, I could have killed just literally everything, I believe. So, but yeah, let's give it at least some chance to take at least some territories. Yep. He should connect this one. Oh, whoa! I blundered. Cool. Okay. Yeah, this is not dangerous. Okay. Okay. Okay, and he defends. Great. He defends his group, so he is alive here as well. Yeah, I'm proud of it. I'm really proud of it. Cool. So we are about to finish quite soon. And pass. Nope. He still has some moves. I would pass here. Pass. It's not very wise to take own territory points, but okay, now it's pass. So it would be trying to play until all the eyes have like 1 point in shape. It's not good, but it's the way how it's done. So score again around plus 30 points. Yeah, but I think this game was more exciting, more interesting. Okay, let's finally have a look at 19 by 19 game. Yeah, let's go for it. Nice corner enclosure. Good. Okay. Creating weak groups is usually a very bad idea, but since I know it can do nothing to this, it's totally fine. Yeah. So this allows me to make some noise in here. Okay. Yeah, it takes some territories, which is good for him. Which is good for him. Yeah, great. So this is currently my weakest group. I need to create some eye shape to make it alive. So maybe a bit more. You see, like it makes use of the fact that I had a gap. Okay. And I will probably make use of this one. Nope, it doesn't. I can still try to split him. Yeah, so this is an example of a ladder. So you see, like the ladder is not good for me, so he saves. This is what I wanted to show you. So he can escape the ladder. So this is good for him. Okay. And he makes use of the cut instantly, which is great. Which is just great. But I take this group, which is much more. So, yeah. Yeah, this card is not working, so it's okay. Whoa, I need to be careful here. If we play this, he would never take the Atari, but here, no, at the moment it's not a snapback. But if we played here, no, okay. Yeah, let's take. Yeah, nice block here. Cool. Yeah, counter attack. This is cool. Now this one is not saved because I'm wondering, does that work in here? So some complicated situations might not always be that clear. So here, 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 yeah, and here, and he has nothing to do, and he would die. Yeah, so this ladder is not working, hence he is not defending the ladder. Yeah, another example of ladder code. So it doesn't defend this stone because ladder favors white. Okay, great. Mm, yeah, it generally tries to make quite a solid shape, which is good. So yeah. Whoa, this was a cool move. A bit pointless, but still cool. Okay. Yeah. It's not really. I expect him to block here as well. Let's just wait. Probably not the biggest urgency. So just wait a little bit until it hopefully makes that move one day. I hope. Maybe not. Maybe not. But I hope it would concede that move one day. Yeah, again, now this ladder is working nicely for, like, it's not working for white, so black escapes. Um, yeah, probably another pattern added could have resolved this, really, because it essentially gives me to destroy all of his territories, letting me in, which is definitely not good for him. Yeah, but anyway, yeah, and here it works. Yeah, so it's a little bit strange. Sometimes it works. So maybe that's another pattern. I don't even know. I mean, really. Okay. Yep. Um. Okay, I just give him some time doing pointless moves so that he could try to make some noise in the position. Okay. Just play some weird moves, yeah. I take territory that is mine anyway. Just want him to take a bit more. Okay. Is this going to live? I wonder. I don't know. Oh, probably it will. Yeah, it probably can live. Yeah, Yosa doesn't have the biggest priority, so Yeah, I can kill this for sure. I can just kill this. Yeah, I don't want to. I want my program to find the save and move. Maybe a bit later. Yeah, okay. And he needs to play one more move here to have a living group. I'm going to be waiting for that. Okay. But at least it's playable, and I think for novice players this might be even interesting to play with this program. Yeah, because really, yeah, I remember those times when I just started with Go. I was listening to literally to everyone. If I had a program like this, I think that would be really beneficial at start. So yeah, I think around 30Q, maybe even weaker. I don't know. Okay, he's not going to take this, so it's fine. So this is fine. Okay, I just really want him to make a move here. But once that would happen, that would potentially end there. What have you done? No way! No! This is bad move. It essentially makes the group dying. What an unfortunate. Hold on a sec. Why did I play this? Maybe if I didn't play this, hold on a sec. No. I want to undo the move. I want to give him the chance. Still, I want to give him the chance. Remove note. I want to give him the chance. But he would not. He wouldn't play into a Terry. So I guess yeah, it's not going to help. Unfortunately, it's not going to help. And even if it takes, still, yeah. Unfortunately, this is just yeah. Even if I give him this, if it just yeah, he won't play into a Terry anyway. Yeah. So unfortunately, this should be. Oh, hold on a sec. Is it a bug? Does it play into a ko? Okay, one tiny little ko bug that I've just found, so I need to fix that. But anyway, guys, yeah, this is it. So yeah, obviously I crushed only one, even though I tried to. I didn't try hard, but yeah. So when it's playing as the human player, it's doomed. But anyway, plays the game of Go. It can play the complete game of Go, which is really cool, and I really like it. So yeah, maybe this is the big move. Go. Yeah, I need to check out which type of move this is to figure out. Yeah, so somewhere I'm not checking for a code, so that's the reason. But anyway, guys, yeah. Hope you enjoyed the video. That's it from my side, and feel free to tinker with this program. So if you're about to just to kickstart with developing a Go playing program, if you want to learn about classic old school implementations, I think this might be a very good place to kickstart with. To kickstart at. So feel free to make use of the source code that I've written. So yeah, that's it from my side. Thanks for watching and see you in the next video. Until then, and cheers.